All right, these problems here, green and red, say to find the following. And we have a bunch of sine, cosine, and tangents we're trying to solve based off of our green and red triangles. Okay, so first off, this green one, it says sine of A, you could say equals what, right? Equals question mark there. And so to do this, remember we want to find the angle we're working with, in this case A, and sine, if we think back to SOH, TOA, TOA, sine, the S, right, sine, cosine, tangent, S has opposite over the hypotenuse, okay? So compared to A, my opposite is 7. My hypotenuse, always across from the right angle, is 25. So all I have to put here is 7 over 25. And that's it. That's all you got to do for sine of A. Cosine of A, again, we're using angle A over here, except cosine is now adjacent over hypotenuse. C for cosine, adjacent over hypotenuse, is going to be 24 over 25. Okay. And then tangent of A, last one for A here, tangent is going to be opposite over adjacent. So compared to A, the opposite is 7, the adjacent is 24, so this would be 7 over 24. All right, now we have to do sine of B, cosine of B, and tangent of B. So now we're using B, sine, we're going to do opposite over hypotenuse, 24 over 25. Cosine of B is going to be adjacent over hypotenuse, right? Adjacent over hypotenuse, so 7 over 25. And then lastly, tangent of B is going to be opposite over the adjacent, so 24 over 7. You might be able to see a couple of patterns here, right? The opposites, they flip, and then these are opposite of each other. If you have the same right triangle using sine of one angle and then sine of the other, you might be able to see some differences there. Okay, let's move to this red one. In this red one, you can see we have a blank. We have an x we need to solve for first. And we can do that by using the Pythagorean theorem. So here I have a 3 and a 5. This is my c squared, though, the 5, or c, I should say. So we're going to do a squared plus b squared equals c squared. For a, that's across from my capital A, it's going to be 3 squared plus b, we don't know that one, I'm going to call it x squared. And then c squared is going to be 5 squared or 25. All right, if I solve here, let's see, it's going to be 9 plus x squared equals 25. This should have been 5 squared first. There we go. Subtract 9 on both sides, and x squared equals 16. The square roots, x is going to be 4. So I'm going to replace x with 4, and now I can go ahead and find my sine, cosine, tangent of angle A, and same thing of angle B. All right, sine of A is going to be opposite over hypotenuse, 3/5. Cosine of A is going to be adjacent over hypotenuse, 4/5. And tangent of A is going to be opposite over adjacent, 3/4. Sine of B, now, B is going to be opposite over adjacent, 4/5. Cosine of B is adjacent over hypotenuse, 3/5. And lastly, tangent of B is going to be adjacent, opposite over adjacent, which is 4/3. Okay, and so there you have it, sine, cosine, and tangent. Remember to use SOH, TOA to help you out with that.